Hello and welcome to this module on PCR mutagenesis. So let me begin by discussing site-directed mutagenesis and doing a brief overview of that. So in site-directed mutagenesis, mutagenic forward and mutagenic reverse primers are utilized. The primers will completely overlap with one another, and they anneal at a sequence of interest whereby the mutation is to be inserted. So here to the right, you can see a figure. You can see that you start with a plasmid, and you can see that here is the region where you want to perform the mutation in the plasmid. You can see that forward and reverse primers are being utilized here, and you can see that they completely overlap with one another, and they completely sit on top of the region that ought to be mutated. Then primer extension produces copies with the desired mutations. So here you can see primer extension happening. Here on this strand of the plasmid, it's a double-stranded DNA plasmid. And here you can see another primer annealing and extension that is happening to produce another mutated copy of the plasmid. The mutated plasmids are further amplified with PCR so that you can have a lot of those plasmids. And then afterwards, digestion is going to be performed. I'll discuss that in a bit. You utilized DPN1 to perform the digestion. DPN1 digests methylated and hemimethylated DNA, so it only digests the parental template strands of the plasmids, not the new daughter strands that have been produced. You can then perform transformation into E. coli, and you can proceed with the next experimental needs. To the bottom, you can see another figure. This is the same concept being outlined, except it outlines it in a different fashion. You can see that you have an initial plasmid here. You have denaturing here of the plasmid. So you can see that it's a double-stranded DNA plasmid. And you can see denaturation here. So you have the interior plasmid, DNA strand of the plasmid and the exterior DNA circular strand of the plasmid. And you can see that you have a mutagenic primer here that's being utilized and a mutagenic primer here that's being utilized. These are the forward and the reverse primers. If you were to sit this inside this copy of the plasmid strand or this strand of the plasmid, you would see that those primers completely overlap with one another. They also sit in the region where you want to change the sequence of the plasmid. You then perform annealing and extension, or you perform extension so that you can create the new strand of the plasmid, and then you perform digestion with DPN1, which digests the parental template strands of the plasmid so that the product is simply the new daughter mutagenic strands. So let me talk about DPN1 digestion. So DPN1 digestion of the parental template is performed, and DPN1 digests the methylated and hemimethylated DNA. These are the parental strands. And then the mutated plasmids can be transformed into E. coli. They can then, in a laboratory experiment, you can perform selection and DNA isolation, as well as plasmid sequencing to ensure successful mutagenesis. There are a couple of things to keep in mind in primer design. This is the resource that I use for this information, and it's a good resource, especially for the primer design aspect. So primers ought to be 24 to 45 nucleotides long. And you have to have 10 to 15 nucleotides, roughly speaking, of completely complementary sequences that are flanking the mutagenic region. You also should maintain a GC content of 40%. Ideally, this would be done in the flanking regions that are flanking the mutagenic region. Another strategy for mutagenesis is the Megaprimer approach. So here you utilize a primer that carries the required mutation. And in the Megaprimer method, you're actually using 3 oligonucleotide primers, 2 of which are flanking primers, and 1 of which is a mutagenic primer, which anneals to the site where you want to change the sequence of DNA. You also perform 2 rounds of PCR here. In the first round, you're using a flanking primer with the mutagenic primer, and in the second round, you're using a flanking primer with a Megaprimer. And so the Megaprimer is going to be produced by this first round of PCR. So you'll see what I mean here. So here to the right, you can see a figure. You can see that you're using a mutagenic primer here with a limited amount of the first flanking primer. What that's going to produce is this Megaprimer that you see here. And the Megaprimer is then used with the second flanking primer. Here you can see the Megaprimer, so that you can produce the new strands that have been mutated in the second round of PCR. You can then perform restriction digestion with DPN1 to remove the parental strands and the parental template strands, that is, and then you can perform ligation so that you can have the mutant clone. And this concludes this discussion on PCR mutagenesis approaches.